Okay, so I hope this is working. So let's keep going. And I feel like since every video takes like about 5 minutes, I can probably finish this in like 2 to 3 hours, and it's probably doable. And with editing time, it's probably approximately like 4 hour works. So it should be doable, and you should be able to see it. So now we're still in the first exam of 2015, as you can see from over here. I hope this works. No, it doesn't really work. I probably try to drag my mouse a bit. It doesn't cooperate. So it's the, oh no, sorry. It's the exam 1 from 2015, fall semester, and we are on question number 3. Sorry about the weird talking. So it says, scientists shine light when with energy greater than the binding energy of platinum on a thin film of it. The same scientists then repeat the experiment with a larger intensity light. According to the photoelectric effect, what should be observed? So if you remember from, I guess, classes, and Dr. Ma should be able to say that the energy of the ejected electron is only somewhat related to, like, as only, it's probably not accurate if I use a biconditional sign. It's just is related only related to the energy of each photon, which there's according to the equation, it's E equals hv, which this is the Planck's constant from above, if you remember it, and this is the frequency, or it equals hc divided by lambda, and this is the light speed, and this is the wavelength. So so the energy of each photon is only related to either its frequency or its wavelength. Actually, they're the same thing with they describe the same thing, but just it's in different terms. So according to the question, it says repeats the experiment with a higher intensity light, but it didn't change like the nature of the light, which is like the frequency or the wavelength of the light. So I guess you can imagine it's like we use whole bunch of table tennis ball to hit like I don't know, a soccer ball, and a soccer ball, maybe soccer ball is not that good at it, but yeah, well, it maybe works. It's a soccer ball in like a, so we're using a whole bunch of like small table tennis or just tennis balls to hit a larger soccer ball that's in a in a hole. So with only the correct energy, we'll remove the soccer ball from the hole, and with the higher energy of each tennis ball, it will probably hit the soccer ball make the soccer ball moves faster. But like if we just use more more tennis ball to hit the soccer ball, it doesn't make a difference. But instead, uh, more electrons will be ejected, since now we got more tennis balls, so we can hit more soccer ball like this. I suppose I should probably draw the hole, but you can understand it. So a higher intensity will lead to more electrons get ejected, but they will be ejected at the same speed. So let's take a look at the answers. Well, it's probably not a very good description model of tennis balls and soccer balls, but I hope you can understand it. That's how I remember it. And well, you probably won't be able to see these videos anyway. uh, so I guess C looks like the correct answer. Yeah, I think C looks like the correct answer, since it says both electrons will be ejected since it's over the binding energy, which is fast enough to remove the soccer ball from the hole, and it's no longer eject. Yeah, so I guess C is the correct answer. So it says electrons are ejected in both experiments, but more electrons will be ejected at the first. No, it should be at the second. I'm sorry, it's not the correct answer. I have no idea what I'm talking about. I'm so sorry. Now filler in a second are ejected, but a sec takes longer. Hold on, what? What the heck? Oh yeah, I'm sorry. C was the correct answer. I read the English wrong. I'm sorry. Yeah, so C is the correct answer, and I have already explained it, and it was not a very good explanation. I'm sorry, and hopefully you can understand it.